I can verbalize.
Okay.
Yeah, the first 2 sections or stuff I can verbalize.
Okay.
All right. So here it is. Find an equation in standard form on the line described. Example. Contains point -1, 4, and slope 2.
Okay.
And standard form is y equals mx plus b.
Okay.
So it would be y equals 2x plus, and then would it be the y 4?
No. It's that. But now we need to solve for b. And we solve for b by plugging in the x and the y coordinate for x and y.
All right.
In other words, the y would be 4, the x would be -1 plus b. And now when you solve for b, you get that.
B equals 6.
Excuse me. I meant to write that as a b. Okay, so b is equal to 6. So now we go back and we know what m is, we know what b is. We can write the equation y equals 2x plus 6.
All right.
Now, is the only format you've learned y equal mx plus b?
No, there's also point slope form.
That's actually a little easier. Why? Because notice what we have. We have a point and we have a slope. And it's a little more direct if you use point slope. Do you know the format for point slope?
I have it in here. It's y minus y1 equals m times x minus x1.
All right. Now, if you want to memorize this, notice that if we divide both sides by x minus x1, we would have m equals y minus y1 over x minus x1.
Slope.
That's rise over run. Okay, so it's an easy way to remember point slope. This way, here. Well, when you have precisely one point and one slope, then the y sub 1 would be what?
Can you say that again?
Yeah, what's y sub 1 and what's x sub 1? If I'm going to use point slope format.
Y of 1 would be the first y on the first set of points you get.
Well, there's only one point. So there's our y sub 1, 4. And then slope is still 2, and the only x we have is that one. So it's x minus a minus 1 or x plus 1. In other words, there's your equation that you were looking for, and it only took one step. Now, if the question said, give me the equation in slope-intercept format, then I have to go ahead and solve this for y. But notice I get the same thing. If I distribute that and then add 4 to both sides, I get 2x plus 6. So 2x plus 6 is correct, but this is also correct. In other words, that is the equation. So unless they specified that they wanted it in slope-intercept format, this would be perfectly acceptable and considerably quicker than having to solve for b.
All right, I understand this now. I was taught all of this last year, but then we just got a packet on it, and I haven't done it all summer, so I don't remember how to do this.
Perfectly understandable. So the two formats you really want to memorize are this one, which is point slope, and this one is probably the more standard one, mx plus b. But both of them can be used depending on the problem. In other words, if they give you exactly 1 point and a slope, might as well use point slope. If they give you the slope and the y-intercept, then you're going to use this one, always. But it's important to also know that both of them produce the same equation. All right, what else you got?
Solve the system of equations, substitution, and elimination.
Okay.
So solve the system of equations is y equals x plus 2 for the first equation, and x minus 2y equals -7.
They want you to solve it by both methods or just either one?
Either one for the first one.
Okay. What's the best method to use here? In other words, different problems lend themselves to either method. This one is particularly good for substitution. Why? Because one of the variables is completely defined in terms of the other. So I can go into this second equation here, and wherever I see y, I'm going to substitute x plus 2. So I get x minus 2 times x plus 2 equals -7. And now we have one equation and one unknown. Let's solve that. It's the next line here. Emily? How do we solve this? What's the next step in solving this equation?
Wouldn't it be x squared because it's x times x?
No. Well, first of all, there is no x times x. It's
-2 times.
Yeah, so the next step is to eliminate the parentheses. When you're solving equations, you want to eliminate denominators and parentheses. So how do I eliminate the parentheses here? What's the next thing I
You multiply the -2 times x and the +2, which is, so it's x minus 2x minus 4 equals -7.
Okay, next step.
Add the 4 to the 7 and combine the x's. So it's
so what's the next line going to be?
-x minus 3. Wait a minute. Yeah.
And finally,
it's x plus 3. I mean x3.
X equal 3.
Yeah.
Okay. Now, this, like I said, this was perfect for substitution. Oh, we didn't solve for y. We got x equal 3. Now, how do we solve for y?
We plug it back into the same equation. So it's 3 minus 2y equals...
Use the easier equation. In other words, since we're solving for y now, we've already solved for x, it's really easy to solve for y using that equation there.
Oh, yeah. I forgot we can use them same.
Y equals 3 plus 2, 5. So always use the easier equation. Okay? Now, what would it have taken for us to be using elimination here? Well, if this is called standard format, okay? Meaning your x and your y are on the left side of the equation, your number is on the right. Well, if I were to put this in standard format, I would end up with x minus y equals -2. You see how I manipulated that to put it in standard format?
Yeah.
Okay. Now, those are my two equations. And since they're in standard format, it is particularly easy to use elimination as opposed to substitution. Those are our two methods. We're always going to choose one of them. Well, if it starts in standard format, choose elimination. If it starts where one of the equation is defined for one variable, use substitution. So how would I use elimination here? How can I eliminate a variable?
We could subtract the x's and we could just subtract all of it down.
You're going to subtract equation 2 from equation 1. And when you do that, you subtract every part. In other words, you do x minus x, you do minus 2y minus a minus y, and then you do minus 7 minus a minus 2. The key is that if I subtract those two equations, the x disappears. And that's what elimination means, is we're going to eliminate one of the variables. So x minus x is 0. What's minus 2y minus a minus y?
It leaves negative y.
What is minus 7 minus a minus 2?
Minus 3.
Minus 5.
5, sorry. Thought it was 4.
Okay. And so now we have y equals 5. So we've solved for y, so the only difference is that when we did it this way, the first variable we solved for was y, but now we can go into either equation to solve for x. Well, this is probably the easiest one to go into. So it would be x minus 5 equals minus 2. Add 5 to both sides, and you get x equal 3. There's our second variable. Okay? So both methods give you the same answers.
Wait, I'm a little lost on how you found the answers.
Okay, let's go back to which step did you get lost on?
No, I got those answers where it was
Okay,
negative
so
y and
minus y equals minus 5, which means y equals 5.
yes.
And now we're going to go into either equation and substitute 5 for y.
So we use substitution and elimination as well.
Well, kind of, yeah, you can say that, sure. We use elimination to start, to eliminate one of the variables, and then we always use substitution to find the second variable. And to find out what x is, we can use either that or this. The second one's a little simpler, so I'm going to use the second one to solve for x. So it's, instead of x minus y equals minus 2, it's x minus 5, because that's what y is, equals minus 2. And then solving this equation, you get x equals 3.
All right, my elimination problem, the first equation is negative 15 minus 2y. I mean, negative 15x minus 20y equals 50.
Okay, that's equation number 1.
And then equation number 2 is 5x plus 30 equals 100.
Plus 30y?
Yes.
All right. The reason I labeled these 1 and 2 is because frequently you have to alter one of the equations before using elimination or substitution. Well, clearly we want to use elimination here because both equations are in standard format. But immediately we don't have any way of eliminating a variable by either adding or subtracting these two equations. But what can I do to one of the equations such that I will be able to eliminate a variable?
You could multiply the top one by 2.
That won't do it. that will make this number 100. But remember, our goal is to eliminate either an x or a y. How about if we multiply the bottom one by 3?
Yes.
Okay, so here's what I'm going to do. I'm going to relabel it 2, and it now becomes 15x. You have to multiply every piece and both sides. So that's our new equation 2. Now, how do we eliminate a variable?
We add them together.
Okay, what do we get?
We get no.
The x's cancel.
7. We get 70 y
equals
250.
350.
Oh, just kidding, 350. Oh, no, subtract.
Okay, and that tells us y is 5. Now, we still have to solve for x. What's the easiest equation that you're looking at that lets me solve for x?
The second one, it has no negatives.
This second one, right?
Yes.
In other words, I don't have to use the second one that I multiplied everything by 3. That's actually more difficult. So let's lose this one and use this one for the reason you said precisely. There's no negatives in it. So tell me what to write in order to solve for x.
5x plus 30 times 5 equals 100.
Which is 5x plus 150 equals 100, which is 5x equals minus 50, which is x equals minus 10. And there's your answers. Okay. Now, there's going to be times where you're going to end up having to multiply both equations by some number. And so I would not only have my original 1 and my original 2, but I would have a new 1 and a new 2. And then you add them together. So that's why I label them with numbers, is because you can frequently end up with a page full of equations and easily lose what you're, looking at.
Yeah.
Okay, what else you got?
I would like to do another elimination problem.
Okay.
The first equation is 2y equals 6x plus 4.
Okay. Second equation?
The second equation is y minus 3x equals 2.
All right. When you're doing elimination, you kind of want them in standard format. Okay?
All right, so we're going to add the 3x to the other side?
No. Remember what standard format is. Standard format is ax plus by equals c. So we want the x in the first place, we want the y on the same side of the equation, and then we want just numbers on the other. So how can I rewrite equation 1 to get it into standard format?
We could subtract the 6x from that and put it over there.
And put it in front. 6x plus 2y equals 4. Now, it's not absolutely vital that the x be first and the y be second. And in fact, in this particular problem, it would actually be a little easier if we made the y first, because equation number 2 already has the y first.
Why don't we do that?
The really important thing is that the x and the y be on the same side, the left side, and the number be on the other. But just to keep things proper, let's switch these two things around. So I'll put the minus 3x there, plus y equals 2. So you see what I did?
Yep.
And why I did it?
Yep, so they'd line up.
Yeah. Now what?
Now we can multiply the bottom by 2.
Okay. So the new 2 is minus 6x plus 2y equals 4. Now what?
And now we can add them together.
And we get, well, if you subtract them, you will eliminate both variables.
Subtract them, and then 2 negatives equal positives, so we just get rid of the x's, and we get rid of both of the y's.
Well,
0 equals.
Here's the problem. These two equations were the same equation the whole time. Notice that my equation 1 is exactly the same as my equation 2. Well, that means we're not going to be able to solve it. In order to solve two equations with two variables, the second equation has to be a different equation. And this is not. In other words, this is the same equation. It's just the first equation cut in half is all it is. And which means the only real equation I have is that one. I don't really have a second equation. And when you have one equation and two variables, you can't solve it. There is an infinite number of solutions. Let me take you back a step here and see if I can explain this with a slightly simpler equation. If I said that, and I said solve that, you can't do it. You got two variables in one equation. X could be 1, y could be 9, x could be 2, y could be 8, x could be minus 5, y would be 15. In other words, there are literally an infinite number of equations or answers. Well, okay, so there's equation number 1. Well, I can't just multiply this by 2 to make up an equation number 2. I certainly have an equation number 2 now, but it's not any different. So it's not going to help me solve for the solution for x and y. And in fact, I won't be able to do it. Having a second equation that's the same as the first doesn't help you at all. You end up with 0 equals 0 by the time you go through all the math. In the same way, there's one other scenario. There's 3 possible situations when you have two equations and two unknowns. What if equation number 2 said x plus y equal 9? Well, that's certainly different. But there's no way that x plus y can be equal to 10 and x plus y can be also equal to 9. That's impossible. This has no solutions. Notice that if I subtract equation 2 from equation 1, I get 0 equals 1. Well, whenever you get one number equaling another number, you know something's wrong. And so this would have no solution. So you have 3 different possibilities. You have no solution, like this. You have an infinite number of solutions, which is what I had if I had x plus y equal 10, as well as 2x plus 2y equal 20. That's an infinite number of solutions, because when I go through the math, I get 0 equals 0. And then if I truly had a different second equation, for example, x minus y equals 5, well, now I can solve it. I have 2 separate independent equations. I'm going to add them together. I get 2x equals 15. Bingo, x equals 7.5.
Awesome.
So when you're dealing with sign elimination, always remember there's those three possibilities. You can come up with a solution, you can have no solution, or you can have an infinite number of solutions. Now, the one they gave you that had no solution is they were a little tricky. They gave it to you disguised.
Yeah.
Notice that if I take the top equation and divide everything by 2, I get y equals 3x plus 2. Same thing I get when I move this 3x to the other side. So these two equations are the same equation. When I say the same, I mean is all one is a multiple of 2 of the other. That basically means they're the same. Okay, you got another one?
Graphing linear inequalities.
Okay.
So it says graph the following inequality. 3x plus 4y is less than or equal to 24.
Okay. For graphing something, we kind of, the way I graph is, first of all, solve for y. In other words, if we can put it into something that looks like y equal mx plus b, we can graph it, right? I'm going to subtract 3x from both sides.
Divide by 4.
And then divide by 4. Now I have the inequality in y equal mx plus b. Pretty easy to graph. I go to 6. I do a slope of negative 3/4. There's my line. Which side of that am I on? Because in order to graph it, I have to shade one side or the other.
Shade the
only thing you need to look to is the y-axis. This tells you everything. What I've circled there. You don't care about x. The only thing you care about is that every point that we're going to shade, the y-axis has to be below this line.
So do we shade the parts that's less than?
Right there. You shade everything below the line. In other words, first I go to the y-axis. I find a point that's below that line. There's an arbitrary point. And I shade everything that is with that. Okay?
Awesome, yeah. I had learned all of this, I just forgot.
Yeah, no, that's they're just reviewing this stuff. It's good. You got one more, or we're about done? But if you got one more that
all
you'd
I
like
wanted
to
to
do,
go over. We covered all of it.
good, perfect.
Yeah. Thank you.
You're welcome, Emily. I will talk to you next time.
All right, talk to you next time.
Bye-bye.
Bye.